number 2. This is Mr. Rengel checking in again. I'll be your host for this lesson. Welcome. We are taking a look at solving quadratics. We've been visiting the concept of imaginary numbers, and then we're going to look at how that relates to solving quadratics. Our objective today is to use square roots to solve quadratic equations, and then use the quadratic formula to solve quadratic equations. So some things that we've talked about in the last few lessons. First, here we'll see the square root of a negative number. The result of square rooting a negative is going to give us an imaginary number. So that's the concept that we've been practicing. So we've grown up knowing that whenever we multiply two numbers together, it always results in a positive. And that's what a square root is you're trying to find what number times itself is equal to that number underneath the square root. And that didn't allow us to do square roots of negatives, but now we can with imaginaries. Number 2, solve by factoring. Anytime we're solving a quadratic that's got a x squared term and an x term, we're going to want to get it set equal to 0. So we're going to have x squared minus 3x is going to equal to minus 3x minus 18 is going to equal to 0. Then we've got a basic quadratic, so we've got a 1 as our first term. We've got a negative 3 and a negative 18. So we're trying to multiply to negative 18, and we're trying to add to negative 3. So if you want, you can pause the video and try it on your own. The two numbers we're looking for would be negative 6 and positive 3. So those are the two values that are going to multiply to negative 18 and then add to negative 3. And then we get those factors, so the x minus 6 and x plus 3 is going to equal to 0. From there, we're going to set each of those factors equal to 0, so x minus 6 could equal 0. And at the same time, x plus 3 could equal 0. And we do a little bit of solving. X could equal 6. X could equal negative 3. So there's our solving by factoring. So that's something that we practiced in the classroom and something that we've been practicing so far in our distance learning. Today, now we're going to learn some new methods to solve these quadratic equations. Number 3, simplify 3 times the root of negative 25. So here's where we have a root of negative 25 where we used to not be able to find roots of negatives. But now we've got these imaginary numbers that we can use. The idea is that every negative number is going to have a factor of negative 1. So when we break up this negative 25, we're going to think of it as 25. And we're going to think of it as negative 1. So those two numbers are factors of negative 25. Anytime we take the square root of a negative 1, that's going to equal our imaginary unit I. So we know the square root of 25 is 5. The square root of negative 1 is going to be I. So when I take the square root of negative 25, I'm going to get 3 times 5i, which results in 3 times 5, 15i. So that root that we take is going to multiply that 3 that's out in front, and there we're left with our result 15i. So we'll be taking square roots of negatives today, and whenever we do that, we're going to have that imaginary unit I. Number 4, evaluate b squared minus 4ac. So this is going to get us ready for the quadratic formula. So quadratic formula is something that we can use to solve any quadratic. So we've talked about factoring so far. This quadratic formula we can use to solve for any quadratic possible. So number 4, we're going to evaluate b squared minus 4ac for 2x squared plus 7x plus 5. We have a quadratic that's in standard form. the x squared term represents our a, the x term represents our b, and the constant term is our c. So the coefficient of x squared is representing your a value, the bx plus c. So now we've got our three values, and we're going to simply just plug those into b squared minus 4ac. So that's going to be 7 squared minus 4 times a, which is 2, times c, which is 5. Do a little bit of arithmetic. 7 squared is 49. 4 times 2 is 8, times 5 is 40. And we're left with our value of 9. That b squared minus 4ac is also a special number that's used in physics types problems. We're not going to really touch on that much today, but in physics, it can determine whether or not you have real or imaginary solutions, and it's called the discriminant. So this warm-up will get us ready for starting our goal today of solving equations using square roots and using the quadratic formula. Solving quadratics by taking square roots, and you'll find that this is very similar to solving the Pythagorean theorem, where we have an x squared term. We need to undo the x squared, and we'll do that by taking square roots. So what we'll see when we're looking at quadratics that we solve in this manner is that they only have an x squared term. There is no x term, so we can use our algebra and we can undo an x squared by taking square roots. So we're going to stick to our algebra that we've been learning since pre-algebra days, and we'll do inverse operations. So if I have a minus 72, I'm going to add 72 to both sides. Once I do that, I'm left with a 2x squared equals 72. From there, I'm still working to get my x squared term alone, so I'm going to divide by 2. And the basics of algebra are you're working backwards through the order of operations. So the last thing in order of operations was adding and subtracting. It's the first thing we do when we undo using algebra. So we're left with x squared equals 36. From there, I'm going to take my square root of x squared, square root of 36, and we'll get x is equal to. Now the obvious answer here is 6, but also think about if you would square negative 6, that also will multiply to 36. So there's always going to be two answers when we solve quadratics. Here our answers are going to be x equals plus or minus 6. Moving on to problem 2. We've got 3x squared equals 15, so we'll get our x squared alone. We'll divide by 3. Divide by 3. And we have x squared equals 5. Undo our x squared by taking the square root. And we're left with x is equal to. So again, anytime we take a square root, there's a positive and a negative that will multiply by itself to get back to your value. But here we have the square root of 5. So we think about perfect squares. Is 5 one of our perfect squares? No. If you cannot simplify your radical, we'll just leave it in radical form. So we get plus or minus the root of 5. Now let's get into two problems that will test our knowledge based on the last couple of days talking about imaginary numbers. So our next quadratic we have is x squared plus 16. I can still solve it using the algebra method, so I only have an x squared term, no x term, so I can use my inverse operations to solve. So I'm going to subtract 16 over, subtract 16, and we have x squared equals a negative 16. Now, just like our previous problems, we're going to undo an x squared by square root. Square root, x is going to equal plus or minus the square root of negative 16. Now in our heads, we're thinking of negative 16 as negative 1 times 16, or vice versa, 16 times -1. And in our warm-up, we talked again about whenever you take the square root of -1, that's going to be I. And then the square root of 16, that's something that we've done a lot. Square root of 16 is just 4. So when we get to our final result, we're going to get plus or minus 4I. So there's our first case where we're square rooting a negative, where it used to be where we could not do that. Well, now we can use that imaginary unit I to take square roots of -1. And let's take a look at our last problem. So we've got 2x squared. We're going to undo the times 2. We can divide by 2. Divide by 2, we'll have x squared equals -16. Okay, and we take the square root, take the square root, and we're going to get x is equal to, very same problem, -1 square roots as an I, and 16 square roots as 4. So we're going to plus or minus 4I. So anytime we just have a x squared term, we can solve using square roots. Next, we'll take a look at solving using the quadratic formula. Look at solving using the quadratic formula. So to use the quadratic formula, we are going to see a quadratic that is in standard form. Your a value is the coefficient of your x squared term, your b value is the coefficient of your x term, and your c value is your constant, your last term here. So a couple things we have to keep in mind. We still have to get it set equal to 0, and once we get it set equal to 0, we can identify what our a term is, b term is, and c term. And the coefficients, we're just talking about the number that's in front of your x squared or your x term. Below is our quadratic formula. So x is going to equal the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we'll be able to plug in our values. Once we plug in our values, we can simplify and find our solution. So we're going to take a look at 3 different problems using the quadratic formula. Example A here, we've got x squared minus 3x equals 4. We have to adjust this a little bit. We'll get the 4 subtracted over. So that's going to give us x squared minus 3x minus 4 is equal to 0. Once we have it set equal to 0, now we've got it in standard form where we have an a term, a b term, and a c term. So my a term is the value in front of my x squared term, which is going to be a 1. So my a is out in front here, and I'm just going to put in blue. You don't have to have it there, but that is going to be a 1 right there. My b is going to be -3. I have to keep in mind that my numbers that come after a negative subtraction sign are negative. And c, same thing, that's going to be a -4 that I'm going to use. Then I'm just going to put this into the quadratic formula. So x is going to equal my opposite of b. So if my b is -3, the opposite of b is going to be 3 plus or minus the square root of b squared. So b is -3, so I'm going to put that back in, -3 squared minus 4ac. Extend that out a little bit. Minus 4 times 1 times -4. There's my a value. And then there's my c value. All over 2 times 1. And then we have a little simplifying to do. So all of our simplifying is going to be this discriminant. That's what we worked on in our warm-up, that b squared minus 4ac. So I'm still going to have 3 plus or minus. Now my discriminant in here is going to be 9. For when I do this -3 squared, that's going to be 9. And then minus 4 times 1 times -4. Well, 1 times -4 is -4. And then this is a -4, so that's going to be a -4 times -4, which is 16. So underneath my radical, I'm going to have a 9 plus 16 all over 2a, which I'm just going to write that as 2. And we continue. 9 plus 16 is 25, and when you square root 25, that's going to be 5. So we're going to have 3 plus or minus 5 over 2. Here's where we get to every quadratic is going to have two separate solutions. Whenever we have this plus minus, 3 plus or minus, we can break this up into two separate problems. So we're going to have first, I'm going to bring this down over to here. You're going to have a 3 plus 5 divided by 2. And we could also have a 3 minus 5 divided by 2. So solving both of those out, 3 plus 5 divided by 2 is going to be 8 over 2, which is 4. So there's one of our solutions. And 3 minus 5 is negative 2 over 2. That's going to be a negative 1. There's our second solution. So 4 and negative 1 would be our two separate problems. So 3 plus 5 over 2, 3 minus 5 over 2 gives us our two solutions. You may have been looking at this quadratic to start with and notice that there are two numbers that multiply to negative 4 and then add to negative 3. So this one actually did factor, but you can use the quadratic formula anytime and you will find your two solutions. So our A is going to be 1, our B is going to be negative 14, and our C is going to be 50. So we can put that into the quadratic formula. So we'll have x equals, and I didn't need to worry about solving it for 0 because it is already solved, set equal to 0. So we're going to have opposite of b, so 14 plus or minus the square root of b squared, which is negative 14 squared, minus 4 times 1 times 50, all over 2 times 1. And again, we'll figure out what the discriminant is. So under there, we got to do a little bit of arithmetic. So the 14 plus or minus is going to come along. And underneath there, we're going to have 196 minus 4 times 1 times 50 is 200. So the negative 14 squared gives me 96. And then the 4 times 1 times 50 gives me 200. So 196 minus 200 is going to give me negative 4. So underneath there, I'm going to have a negative 4 all over 2. And we continue. We've got a 14 plus or minus the square root of negative 4. So here we see that square root of a negative. So take a minute to think. When you square root a negative, what type of number are you going to get? If you said imaginary, you are correct. So 14 plus or minus, square root of 4 is 2, square root of negative 1 is I. 14 minus plus or minus 2i over 2. Now from here, the i's and the imaginaries and real numbers cannot add together, but there is some more simplifying we can do. When you're dealing with the quadratic formula, you can break apart this sum. If you have a sum up in the numerator, sum or difference, you can break that apart. So this would also look like this. It would look like a 14 over 2 plus or minus 2i over 2. So it's a sum or difference. That means that the denominator is the same for both those fractions. And then we could continue to simplify. That's going to be 7 plus or minus I. So there would be our final result. And that accounts for both answers. 7 plus or minus I is 7 plus I and 7 minus I. Is that equal to 0? So my A term is 1. B term is negative 4. And C term is 8. And we'll put this into the quadratic formula. X is going to equal opposite of B, so 4 plus or minus the square root take your b squared, negative 4 squared minus 4 times 1 times 8. And once we get that, we'll put it over 2a, and we start finding our discriminant. So underneath there, that b squared minus 4ac, we'll see what happens. So negative 4 squared is right here, minus 32. So negative 4 squared is 16. 16 minus 32 is a negative 16. So we'll have 4 plus or minus the square root of a negative 16 all over 2. And square root of negative 16, this is the third time we've seen that one, that's going to be 4i. So we're going to have 4 plus or minus 4i over 2. And this one we can break apart again. So anytime we have that sum in the numerator, we can break that up. And that's going to give us a result of 4 over 2 plus or minus 4i over 2, which both 4 are divisible by that 2, so we're going to rewrite this as 2 plus or minus 2i. And there's going to be our 2 solutions. Thanks for joining me today. That was our learning target of solving by taking square roots and then also solving using the quadratic formula. So good luck. You can start your class check, and happy solving. We'll see you soon.